Okay, sorry about that other video getting cut off. That was a combination of me factoring weird, and then also I unplugged something. But it doesn't matter. What does matter is calculus. Okay, so I found the derivative of my x equation. I found the derivative of my y equation. And now I can rewrite this. So I have dy over dx is going to be equal to 2 cosine squared theta plus cosine theta minus 1 over negative sine theta. And I'm going to just actually write this as like 1 plus 2 cosine theta. Okay? Now, what we were asked to do is find the points and where we have vertical or horizontal tangent lines. Well, let's do that. So let's do our vertical tangent lines first. Right? Let's do our vertical tangent lines first. And to do that, I'm just going to set my denominator equal to 0, right? So I have negative sine theta times 1 plus 2 cosine theta. I'm going to set that equal to 0. Well, when is negative sine theta equal to 0? Well, when theta is equal to pi, or 0, yep, 0, pi, and then we have this would cosine at negative 1/2, so that would be at 2 pi over 3 and at 4 pi over 3. Okay? What about our horizontal tangents? Okay? Well, our horizontal tangents, I'm going to set my numerator equal to 0, so 2 cosine squared theta plus cosine theta minus 1, set that equal to 0. And if I do a little bit of work here, I can do some factoring. So I've got 2 cosine theta, what's this going to be? Plus, that's a plus, right? So plus 1 minus 1. So theta equals, what are we going to have here? This would be a positive 1/2. So when it's pi over 3, plus or minus, and then when it's negative 1, when it's pi, right? So notice that we have this pi here and this pi here are the same, so we actually have no conclusion of what's happening at pi, right? There's no conclusion there, and that's from up here. When dy over dx, dx over dy, when those are equal, there's no conclusion. So they're both equal to 0 there. So, but we do have our vertical tangents are going to be at 0, 2 pi over 3, and 4 pi over 3. And our horizontal tangents are going to be at pi over 3 and negative pi over 3. Okay? And that's it. That's when tangency is happening on this graph, 1 plus cosine theta. Okay? Let's do a little bit more examples here. Tangent lines at the pole. So, if f of a equals 0 and f prime of a does not equal 0, then the line theta equals a is tangent at the pole to the graph of r equals f of theta. So if we find zeros, they can help us find the tangent lines at the pole. So we've been given this rose curve, r equals 4 sine 3 theta. Okay, so let's first find dy over dx. Well, x is going to equal 4 sine 3 theta cosine theta, and y is going to equal 4 sine 3 theta sine theta. And I'm not going to go through all of this math, but here's dy over dx. You know, to find this, we would find this derivative and this derivative, and then we would divide them. And so our derivatives here, we're going to have 4 sine 3 theta cosine theta plus 12 cosine 3 theta sine theta divided by, that was our dy, negative 4 sine 3 theta sine theta plus, oops, that should be a 12, not 11, 12 cosine 3 theta cosine theta. Okay, so there's our derivative. We did that part. And then we're asked to calculate the slope of 3 tangent lines for the curve of the pole. So it's 0, pi over 3, and 2 pi over 3. Okay, so we're going to first evaluate. So dy over dx evaluated at 0, at theta equals 0. And you would use your calculator for this, but anyway, I'm just going to give you the answer. That is equal to 0. Okay, and then let's evaluate dy over dx evaluated at theta equals pi over 3. Again, you can use your calculator. This is equal to radical 3. And then let's evaluate dy over dx at theta equals 2 pi over 3. And if we get that, we're going to have negative radical 3. Okay? So you can see, oh, I was going to graph this. If I graph 4 sine 3 theta, 4 sine 3 theta, don't freeze, I graph this, okay? What we're asking for are these tangent lines at the curve. So at 0, it looks like we're probably going to have one right here. And at radical 3, we would have one, is that right? Yeah. Anyway, we're going to have one like here, and then like here, right? Okay. So let's find the locations of all the horizontal tangents. So, find the locations of all the horizontal tangent lines. Well, we know that when dy over d theta is equal to 0, we have 4 sine 3 theta cosine theta plus 12 cosine 3 theta sine theta. That's what we're setting equal to 0, right? And when this happens, theta is going to be equal to 0, pi over 2, and pi. Okay? So if, sorry students, that was confusing. I accidentally hit the camera with my calculator. So pi over 2. That's not what I wanted. So my x value, the point on the curve in xy coordinates, if I go, let me pause for a second here. Okay, I'm going to finish this example, even though there's not going to be anything like this on your assessment, and there's not going to be anything like this in your homework, so I don't know why I'm doing it, but whatever. Let's find all the locations of the horizontal tangent lines. Well, in this scenario, theta is approximately 0.65905 and approximately 2.4825, okay? So if we find these points in xy coordinates, we've got our x values, we've got our y values. Well, when x is 0, y is 0. When x is 2.91, y is about 2.25. When x is 0, y is negative 4. When x is negative 2.91, y is 2.25. And then when x is 0, y is 0. Okay? So this is going to look something, it's really ugly, but it's kind of like this, right? So here is 2.482. Here is pi. Here is pi over 2. Here is 0.659. Here is 0. And this entire graph is dy over d theta. Okay, so these are our horizontal tangent lines. We're using that dy over d theta, right? So what's our absolute minimum? Well, our absolute minimum is going to be like a leaf tip, right? Which in this case is going to be at 0, negative 4. And our y maximum values are going to be plus or minus 2.91 and 2.25, right? Okay, so let's just finish up this example with 2 more questions over here. We want to find the 3 points where r is a maximum and show that the tangent line is perpendicular to the line segment connecting the point to the origin. Okay, well, r maximum, so our first step is that r maximum is when sine of 3 theta is equal to plus or minus 1. So in this case, 3 theta would be equal to pi over 2, 3 pi over 2, and 5 pi over 2. So theta, once I divide it by 3, is going to be equal to pi over 6. Pi over 2. 3 pi over 6 is pi over 2. And, 5 pi over 6. 6. Yes, that's right. Okay, so then we're going to evaluate dy over dx at pi over 6. and then again at pi over 2, and then again at 5 pi over 6. Okay? We're going to evaluate all of those, right? When we evaluate at pi over 6, we get negative radical 3. Pi over 2, we get 0. 5 pi over 6, we get radical 3. So the perpendicular tangent here is going to be the tangent, of 5, or why do I keep doing this, of just pi over 6. Here, our perpendicular tangent will be of pi over 2, and here our perpendicular tangent will be of 5 pi over 6. Here we go, pi over 6. That's a 6. Well, here this equals radical 3 over 3. This doesn't exist. And this is negative radical 3 over 3. So, if we have our graph here, this is what this kind of looks like, right? Our tangents are going to be here, right? And they're going to be perpendicular. These are all perpendicular. Not a great drawing, but it works, okay? So, we want to finally write the equation for the tangent line that passes through the point r theta at 4 pi over 6, okay? Well, the regular point at theta equals pi over 6 is going to be 4 cosine pi over 6 and 4 sine pi over 6, which is equal to 2 radical 3, 2, okay? So there's our xy. And that's our point. And then here, our m value, our slope at pi over 6, well, we can calculate dy over dx at pi over 6 is equal to negative radical 3, okay? So then now we can finally write the equation of our tangent line. So y minus 2 is equal to negative radical 3 times x minus 2 radical 3. And I would just stop there. That's it. That is perfectly done. And I think that's good enough. Okay. Any questions, leave them in the comments. And I really hope I get to see you soon.